che lo že enkrat lutamo, no. Nekaj se mi vodi časovno, joj. Pa Zoom tudi ne dela nič. Jej.
Yes.
Oh, končno. Come on. Can I show? I will just give. Bom poklical Marka, pa bomo videli, kar bo. Hi Mark, where are you? I'm here in the Zoom call, but you're not even here.
I am right here, April Fools, everybody. Hello. Hello, everyone. Welcome to Stay Curious here at the American Space Museum. I'm Mark Marquette, of course, and this is Rok Kete. Rok, how are you?
I'm still alive. How about yourself?
Great, great. Trying to do a little April Fool's joke for y'all out there, thinking he was on a Zoom call. Thank you for doing that. This young man is Rok, R-O-K is his first name. K-E-T-E is his last name. There it is on the bottom there. And you are going to learn things you never heard about on the Artemis service module, but more importantly, you've never heard these things about the lunar outpost, that this young man is an engineer working on the Lunar Gateway. So, Rok, welcome. How you doing?
I'm good. How about yourself?
Well, I've enjoyed meeting you. He's like a new grandson to me here because he's hung out at our museum. And tell everybody why you're here with the European Space Agency at Cape Kennedy.
So currently they're in the Cape, about 11 miles from here. There is a rocket, one SLS rocket, sitting on the pad 39B. And it also has a European patch on it. And there is a special reason for that, because some an element of that rocket actually comes from Europe.
That's right. It's an important element of Orion is the service module. That's the cylindrical section behind the Orion that has all the stuff it needs for instrumentation and the survival of the astronauts for long duration and all that. And you're going to hear a lot about Europe's involvement with that. You're here to watch Crew Dragon go off April 20th is now the date, 4/20. Astronaut commander is Kyle Lengren, a NASA astronaut who has spent 141 days on Expedition 44. We have a rookie pilot, Robert Hines, and a rookie specialist, Jessica Watkins, who's an Artemis astronaut, going to be making her first trip to space. But you're there to support Samantha Cristoforetti. Yeah. And she's quite a popular astronaut who spent 200 days on Expedition 42-43. And Cristoforetti from Italy. Yeah. Tell us a little about her and your support.
So she will be flying. This is going to be her second mission to the ISS. I don't think she's going to be a commander, but there was a plan that she would actually take the control of the space station for a couple of time. But because of the mission has to be shortened because of the ISS occupations, she's probably not going to take this role this time around. But hopefully on one of the future missions she will.
Yes, We're excited to have a European commander always on there, and we are going to learn a lot about Artemis here, the Gateway thing, and Kyle is going to be a good friend of our museum. I talked to his superiors today on a Zoom call. That was exciting to talk to Bernard Foing. Yeah, Foing, who's the team leader. And what the buzzword here is EuroMoonMars, all right? This is what this gentleman Rok is all about, and his team is EuroMoonMars. And when they're going to create this new Gateway space station, you're not going to believe how the plans they have for it to make it more of a universal spacecraft. So I'm going to let him talk about that in a minute. Rok, we'll get back to you. You've had a great visit here, but you're no stranger to America. Tell us why you were here before.
So before I did some work at the Johnson, and I'm finally here at Kennedy.
Yeah. You can't wipe the smile. You can't wipe the smile off this kid's face. He's 23 years old. He spent 3 years at Johnson Space Center already, right? So you're a very Americanized European. Tell everybody where your home country's from.
So my home country would be Slovenia. It's a small country, basically squished between the couple of larger countries like Italy, Austria, Hungary, and Croatia.
This is part
quite
of
small.
Yugoslavia, and us baby boomers would think of it as that. So, and when we're looking at the green screen behind us is one of the pieces of artwork that you brought. What does that show us there, Rok?
That's one of the graphics of the art for the Artemis program. So we are having basically an astronaut. It will be here, and we are having like a robot here, some surface equipment, and at the background we are having the Earth, and somewhere over here there should be also Mars visible.
Awesome. All right. Well, we're gonna get into some of his technical slides of the Artemis service module configuration. Orion is built by NASA, and ESA is building the service module, and you can't have one without the other. So this is a great symbiotic relationship. But Rok, we're going to kick off our program here by thanking the Hyatt Place, Titusville, and Cape Kennedy for supporting our program here in our Hyatt Place studios inside the American Space Museum. Just like this young European engineer said, 11 miles from where the SLS rocket is on the pad. And we're going to see a picture that you took of it here in just a minute. But hey, we enjoyed a launch this morning. Not this morning, about 12:43 today. And in fact, that is you on the far right, the silhouette there. And of course, the VAB. What'd you think about that?
If only we knew they were going to actually launch it and we get to this Kennedy and see it from even closer. But yeah, it was a nice view. We saw it for a couple of seconds before it disappeared in the clouds. But the sound was just amazing, yeah.
Well, yeah, he's bemoaning the fact that he has a credential to be out at Kennedy Space Center and could have watched it out there. But the weather didn't look good, and you made the right call. We had a good time together, and
definitely.
You got to see some of the local people out there, the rocket hobos, as we call them, a good crowd out there. Disappeared in the clouds right away, and then it reappeared a couple times. But that's a photograph that I took and posted on Facebook. And we want to remind everybody that Saturday, April 16th, we're going to celebrate the golden anniversary of the dawn of the space shuttle era at Hyatt Place in Titusville from 9 to 5. It's free admission. We've got 2 astronauts, Mike McCulley and Winston Scott, scheduled. 3 launch directors, Jim Harrington, Bob Seek, and Mike Leinbach, who launched 111 of the 135 shuttles between those 3 men. And who knows when they'll get together at one place again. So we're going to be bringing this to you live on our Facebook, Spotify, YouTube, and Twitch platforms. Okay, so you out there, Robert Law, I know you'll be anxious to watch the whole day's festivities. He is in Dundee, Scotland. And we have a lady named Ophelia Sauterelle who's in Normandy, France, watching. Oui, to you out there. And so we're going to take you along with us, and so please, stay curious. Tom Usiak took this photograph. Tom's going to be our guest Monday on Stay Curious, going to tell us about how NASA used all those photos that he and his brother took, and other photographers, how they turned them into slides and lithographs and prints for the media. And Tuesday next week, we're going to have the voice of NASA, Hugh Harris, give us the shuttles of April. This is April 1st, but we're going to start celebrating the shuttles of April next week. 16 space shuttles launched in the month of April, and there's some fascinating missions there. Of course, this is Friday, and we pushed Triple T to the side. He acquiesced for this young engineer from European Space Agency who's going to tell you things that you never heard before, I guarantee you. So stay tuned for that. But we want to wish a happy birthday to this doctor. This is Dr. Bill Fisher. And Bill Fisher was one of the early astronauts and spacewalkers. He flew one mission, STS-51I, in 1985, on Discovery. They deployed 3 communication satellites, and then he did 2 spacewalks with James Van Hoffen to repair an alien satellite. This was what we thought the space truck was going to be doing in 1985, and then, of course, a half a year later, the tragedy of the Challenger changed all that. And Bill became a regular physician. Of course, he's well known for marrying Anna Lee Fisher, the astronaut husband-wife duo. They were married in 1977. They have some children, and they divorced in 2000, I understand. But Bill Fisher is very interesting. He collects Bill Graham Fillmore posters for you rock and roll heads out there. And he is an amateur luthier. You know what a luthier is? They make guitars.
Oh.
Yeah, a luthier makes guitars and wood instruments like that. Napoleon-style mandolins is his expertise there. How cool is that? So quite an interesting gentleman there, Bill Fisher. Happy 76th birthday to you. Born April 1st, 1946, from Dallas, Texas. So, well, welcome to Stay Curious. I was so interesting talking to Rok's engineering friends this morning at 11 o'clock, 5 o'clock in Europe. And we hope that Bernard and Adriano and Serena are watching Stay Curious. We'll know that they're watching. Marty Winkle, my co-producer working our Streamlabs engineering thing, is nodding that they're on watching you. So don't get nervous, kid, and speak up there as you're sharing all this with
Hopefully,
everybody.
Bernard, I'm not letting you down.
That's right. So I'm going to kind of turn it over to you, and I'm going to show you the button to push forward on the slideshow there. We want to just know a little of your background. You grew up in Slovenia, and where did you go to school, and how did you become so smart at such a young age?
First of all, I'm not really that smart. I wouldn't say that. So I'm not that smart. I just had a really big luck meeting the right people at the right time. But yeah, I went basically in my primary in high school in my hometown in Slovenia, then continue at the University of Ljubljana studying mechanical engineering, and we'll see what the future will bring on that front. But throughout the school I was interested. First I started with astronomy. I was part of the astronomy club in the high school, and in the high school we were doing mainly astrophotography, doing some remote observatories, planning those two. And on the way I got actually interested into the spaceflight itself. I did a concept for an interplanetary transport system when I was still in high school, presenting to my mentor. He then presented it forward to his people. He was studying at Houston, at University of Houston, and that's how I got basically into a space flight
So
section.
you did a high school project on interplanetary propulsion systems.
Transportation system.
And this is what he's going to talk about here in a little bit,
Right.
folks. You're not going to believe what the Europe's real plans are for the future, and I think it's a brilliant idea in there. So you've learned at a young age. It's not always not what you know; it's who you know, and the who you know people are the stellar scientists and engineer people at the European Space Agency. And I told you that we talked to Alex Carl, a Eurocom, about a month ago. I meant to reach out to him. I'm going to reach out to Alex to watch us again, but we talked to him in Cologne, Germany. But you're right here in America, like we said, 11 miles from that Artemis rocket that's on the pad 39B. So
then I joined the EuroMoonMars Team.
So EuroMoonMars Team. Look at that logo there.
It was in December of 2020. And our group is basically, we are doing a lot of different, we are working on many different projects at the same time, but our focus is actually the astronaut training and analog missions. So this actually means we get a crew of astronauts. Usually those are the students, because why not?
Right.
They are the best to get. And we put them like in a analog habitat, and we basically simulate how a surface mission, let's say on the Moon or Mars, would look like.
Now, where are these? There's several areas that ESA is using for simulating habitats on Moon and Mars.
So
where are those at, Rok?
We are having a habitat at high seas at Hawaii. There's another one in Iceland, inside the lava tube. We also have a bunker.
Inside a lava tube in Iceland?
Yeah.
There's a simulation of the Moon or Mars there?
The Moon.
The Moon,
Yeah.
wow.
Because where the astronauts will eventually be living on the Moon, hopefully, they will have to get some additional radiation protection in form of the regolith that will be covering their
And your team leader of the EuroMoonMars, Bernard Foyne, he was trying to organize a field trip for you to Iceland today there with your team, right?
No, to another center.
Oh,
But
another center.
But they were arranging some future analog missions during the meeting, yeah. But yeah, so this is our main purpose, is getting basically astronauts trained.
Cool. Good. And you're going to see the habitats that he's training them in.
Yeah. But today I'm going to talk about Artemis mission. As we already mentioned, there is a rocket
That's
sitting
your
on the
photograph
pad.
there.
Yeah, taken on Monday from the rocket actually at the 39B. That's like a couple of yards away. In the front, you can see the preliminary fence around the launch pad. Yeah, so I got
You got
pretty
as close as you could to the fence there.
Probably, yeah, without getting arrested.
What was your impression of that, Rok?
I mean, it's just magnificent to see it up there. Finally, after all of those years, it's finally out there where it's supposed to be.
Good.
Sadly,
yeah.
this time only for a short time, but the next time it's going to roll out, it's hopefully going to be the last time.
We're excited about that.
Yeah.
Of course, they're going to do a wet test, they call it, fill the tanks up, do a simulated countdown with a woman launch director for the first time, Blackwell Thompson, and she's going to do the countdown till... When do they cut it off? You don't know, do you? 10 seconds or something till they're not going to ignite anything.
T-minus 5 seconds, just before they ignite the engines.
All right, just before they ignite the engines. All right, and those engines are Marty Winkle's SSMEs that he was the launch process service on there. There's 4 shuttle engines that will be used for the last time because they'll be dumped in the ocean, and you'll hear a lot of stories about that. But they're going to pull it back in the VAB after this test, do a lessons learned, and then it'll go back out to the pad, hopefully the end of May for a launch in June or July, and you'll be back for that, won't you?
Hopefully, yeah.
Hopefully. Hopefully so, because I want you to get me close to it there.
We'll see.
All right, we're going to hear about what you're involved with now.
And so there on the rocket, as I mentioned, there is a European ESA patch on the because it indicates that an important element of this Artemis 1 mission actually comes from Europe, and that would be many of your viewers probably know that Europe is providing the European Service Module for the Orion vehicle. It's basically based on the ATV. That was ATV was autonomous transfer vehicle, was European ISS resupply vehicle back in 2000 and 2010s. They flew 5 missions in total. It was the largest resupply vehicle. It was docked with the I think with not the Zvezda, Zarya module.
Okay.
And it also provided the reboost to the International Space Station. So yeah, it was a really large spacecraft.
Very important in the early days of the ISS to get heavy payloads up there and get us up there. This chart here shows you the Apollo command module attached to the service module, and then Rok is saying that in the middle, the European ATV becomes the
service module,
module on Orion there. So you can see things are condensed in size because you don't have a payload to take up there. Yeah. But so that engine part on the back side, the picture above Rok's head there, that's we're going to see more pictures of that.
Yeah.
There it is right there.
And this element will actually provide basically everything that's needed to operate the Orion spacecraft. We're providing power, that's why we're having 4 solar panels. We are providing the thermal control. We are regulating the temperature inside the Orion, providing data link and telecommunications, and basically sensors. So guidance, avionics, everything.
Remind everybody the crew capacity for Orion.
So the Orion is designed for the Artemis mission is designed for 4 astronauts, but it can take up to 7 astronauts.
Okay.
Eventually for the future missions, the capacity can be increased, but for now we are keeping it. The Orion will be flying only with the 7 astronauts on board on each mission, except on the first mission there will be test dummies, so no astronauts there.
Now this is going to go to the lunar outpost, all right, that we're going to talk about here in a minute. And at that lunar outpost is supposed to be the SpaceX Starship. That's what's going to land on the moon. So this is really the ferry, her Uber to the lunar habitat that's going to be orbiting the moon, right?
Yeah, that's like an Uber to get it from the Earth orbit to the lunar orbit and then bring it back.
Okay.
Hopefully we don't screw anything up. But that's not the only contribution of the ESA to the Artemis program.
No, this is the best part, I think.
So ESA is also providing so Europeans are basically building 3 out of 4 initial gateways.
Let's go back to that one
modules.
and tell us a little more about what we're looking at there.
Okay, so here we're having Orion spacecraft that is approaching the
Right,
gateway.
there's the Orion spacecraft, but right there, right.
Over me, here is the Lunar Orbital Platform Gateway. This is like a space station that will be orbiting in the near rectangular polar orbit around the moon.
Well, they got a football goalpost there. No, those are actually solar panels that are coming off there, and this it actually looks like a
Those are big solar panels.
our football, not your football.
Oh yeah,
not soccer. There you go.
Right.
All right, now you can talk about the 3 out of 4 habitats
that's-
ESA is doing.
So ESA is providing the Esprit. This is like a utility module for the gateway, and also international habitat modules. Those will be flown later, but the initial configuration of the gateway includes a PPE, power and propulsion elements. That's like a spacecraft bus. That's an unmanned vehicle, and also a HALO, habitation and logistic outpost. That's a habitation module. And this one is also, the HALO is actually provided to NASA by Northrop Grumman, who won the contract. But the the module itself is going to be built by Thales Alenia in Turin, in Italy.
Okay.
So this is why I put it in gray, because it's not the direct ESA's contribution to the program, but it's European contribution, let's just say.
Okay.
But that's not all. So ESA will be providing the communication for the crews that will be while they will be doing the surface missions, and to the rovers they will be driving down on the lunar surface. So in that regard, the ESA is developing Lunar Pathfinder. That is going to be like a communication satellite that will be orbiting the moon and providing the data link between the crews on the surface, the gateway, and the Earth.
Why do we need to put a satellite in lunar orbit for communications? Why can't they just beam it to Earth?
So it's, first of all, it's easier to actually have a satellite closer to you, and in this way you can also transfer more data. And you don't really have to carry as big dish as you would have to in that case.
Also opens up the possibilities of landing people on the back side of the moon,
yeah,
right? And tell, where are we going to land on the moon?
For the Artemis mission, the proposed landing sites are near the Shackleton crater on the south pole of the moon, and because those are not really don't really have a direct link with the Earth all the time. You have to have like a relay satellite in orbit around the moon, so the signal can be actually transmitted between the Earth and the crews on the surface.
So instead of the Apollo missions where they orbited around the equator of the moon, we're going to actually orbit, and your lunar outpost is going to orbit from over the poles.
Yeah.
For the appropriate landing.
And if you imagine
but
this,
I know the answer, but why are we going to the South Pole? Why is this Shackelford crater interesting to scientists?
Because there is supposed to be quite a large ice deposit.
Ice,
yeah. And it also
it never melts because there's no sunlight.
It's in permanent shadow.
Yeah.
And this also allows for some of the organic molecules to remain untouched since the formation of the moon. So hopefully we can get some really good science out of that.
And
too.
we're pretty sure a lot of this ice and water came from comets that have seeded our solar system, bombarding the moon. Now, Rok is an amateur astronomer like myself, and he's been since a boy. He said he's had telescopes, and I always think it's interesting that it always goes back to astronomy. You know, that there's always a connection with the wonder of gazing at the moon, and controlling the moon's tides and so forth. And now it might harness the very beginnings of life in some of these craters seeded from comets. But it's hard for people to understand millions of years and billions of years, Rok. But that's how this water's developed over just millions and millions of years of being hit by comets and cosmic debris, right?
Yeah.
Okay.
and we are not done yet.
No.
So
Another
Europe-
European phase of
Yes, sir.
Artemis.
So Europe is also proposing to develop its own resupply lunar gateway resupply vehicle. We would call it a moon cruiser. It would be built by Airbus, and it would basically build on a heritage of the ATV. It would be quite similar to the ATV. So the resupply vehicle that ESA used to resupply the ISS, but this time around the concept is to split the service module and the pressurized section apart, so we can use also the service module to transport other components to the lunar orbit.
So you see two moon cruisers there, right?
Yeah,
there's
from
two
two.
of them there docking with the Lunar Gateway.
This way, we don't really have a single-purpose vehicle, so we can also transport. We are not limited to only transporting the crew supply to the gateway, but we can also transport some the lunar surface hardware to the lunar orbit.
Okay. And that kind of hardware is going to be things to build habitats and science experiments and stuff,
yeah.
right?
And that's when we come.
Surface there, right?
Yeah. So
Are any American companies helping you? Fabian from Peru. Okay, and Chalid Zan. Hello, Mark Usiak, and Cynthia Rossi, and Tom Usiak
Yes.
is going to be here Monday. And we've got Chris Callie. Hello, Chris. Glad that you're watching us. Rich Jones. You got your manager Bernard's watching. Hi, Bernard. Hope he's doing you justice there. This is so fascinating, and I know a lot of us Americans have never heard about any of this yet. So, and Teresa Doyle, shoot. Paul Forrester. Hi, Paul. Christopher Mick is an educator. He's been here in our museum. John Mosby, Larry Pushkar. Hi, Larry, and Apogee MC, right, Marty? Apogee. I finally got it right there. So anyway, we appreciate this. Is people watching us all over. Those are the people on Facebook, and we've got other people on YouTube. And you can see our other shows on YouTube. We've got a whole collection of them there that we posted since July. And we've done 2 years of Stay Curious on Facebook, and every one of those episodes is on there. And Marty and I literally started out with showing people zooming in on sheets of photos and so forth. And now we've got this beautiful program on our Streamlabs that Marty's running there. I remind you all that Marty, my co-producer, was involved on the lunar module of Grumman. He is an electrical engineer on every one of them. Those descent stages, 6 of them sitting on the moon right now, and those ascent stages that blasted our 12 brave astronauts on 6 missions off the surface of the moon. So he's what we call a national treasure, and you'll be a national treasure in your country someday, young man.
That's quite a high feat to achieve.
So that's a little bit of the business here, and on the last half of the show here, we're going to pay attention. This is some good stuff now.
Before we jump to that section, so please everyone, if you are having any questions, please feel free to post them in the chat.
Yeah. If you got
We'll
any
try to
questions-
answer them. We might not be able to answer each of them,
Right.
or we are not allowed to answer them,
Yeah.
but we'll try our best.
We are very good that they are allowed to talk about some of this stuff, and I'm amazed at what we're going to hear here up closer. But tell everyone a little bit about your impression of the American Space Museum. You've been camping out over the visitors complex with the Atlantis and all those rockets in the rocket garden.
So
what about our museum in your eyes?
So I was actually recommended your museum by my coworker, who said it's like a hidden gem here in Titusville, and he
Hidden
was
gem. Thank you.
really the right one. I really like that you're having people who actually had their hands on the space hardware and can really tell the stories that were happening behind the scene.
Mm-hmm.
Those you don't really hear in the visitors complex, let's say at Kennedy.
Good,
That's very nice.
good. Well, thank you, and we're gonna see you many more times when you come over here for these missions here. So, all right, next up here we've got the.
So now I'm gonna talk.
Yes.
Present
no,
you about
I'm gonna be quiet. And you talk.
My primary project, that is Lunar Orbital Platform Gateway. So, as you know, the first phase of the gateway that's currently being scheduled is to send a power and propulsion element, PPE, and habitation and logistic output outpost to the cislunar space, so into near rectangular polar orbit around the moon on a single
That'll
launch.
be launched on a Falcon Heavy.
Falcon Heavy in 2025, hopefully, if there are no additional delays. And after they arrive there, they will serve like a transfer element between the Orion and the HLS, Human Landing System, and that's going to be Starship for initial Artemis launches. But we are trying to look over that, try to look even further into a future, and really try to make as much out of the that outpost that will already be there and utilize it for other purposes as well. So it's not like only a single. It's not like an element that can be only used for a single purpose. As of now,
Yes. No. I want to just backtrack on that. What Rok is saying, to repeat, these vehicles they're designing don't have a single purpose, meaning just the moon, right? Well, where else are we going to send these, Rok?
Well, hopefully also further than cislunar space, beyond our Earth's environment.
To asteroids?
Potentially asteroids. We can take you basically anywhere inside the inner solar system, beside the sun and a couple of Venus, Mars, and up to the asteroid belt.
And you're going to tell us the propulsion systems involved here in a minute. Here, I'm getting ahead of myself, but I want everyone to catch up to speed here. That Europe is not thinking of just a one-purpose lunar outpost. All right, they're thinking that maybe when the dew dies down on the excitement of going back to the moon, that like with Apollo, what are you going to do with all this hardware? And you've got plans for that. Yeah. So, Marty, you got a question?
Yeah, Dave Stange asked, do you really feel that Landon will be ready in time?
For the Artemis one?
The question is from Dave Stange, do you think a lander will be ready in time?
I mean, SpaceX proved itself in the past. So we are keeping our fingers crossed.
We're talking about the big Starship.
So we have to keep the fingers crossed and let the engineers do their work. They are having wonderful people working out there, and they are doing really miraculously.
Good. That'll keep the door open for a job at SpaceX for you, so if you would know. No, this is a pivotal next 6 months for this Starship. This is where they're really going to try to orbit it and all that sort of thing. I know you keep up with that.
I know.
This has got to go right this year. We'll know in a year from now. We'll really know
where we are.
Yeah.
But definitely the HLS or the lunar lander is currently the bottleneck in the development of the Artemis program.
Okay.
But they picked probably the best company they could for such job.
Do you think that they chose the best company to do it over Blue Origin?
Well, I cannot say publicly.
Okay, all right. I'm not trying to put you on the spot there.
Yeah.
No, there I am.
Okay.
There's your face.
So just to give you a bit of a background, so current architecture for the Gateway actually proposes that station will be actually utilized only like a month per year, while the crew will be two of the astronauts will be on the Gateway, while other two will be on the surface of the moon. They're doing the surface mission. So, but we are looking, if we are already having such a wonderful element up there, let's try to make most out of it as much as we can. Why not to have a permanent crew up there doing the continuous research and science, and maybe even use it for some extra missions. So running multiple missions in parallel to each other. This also lowers the cost per mission and enables you to really gain the full potential of such outpost.
Okay.
That's our idea.
Not just a lunar mission going on in the Gateway, but other science could be going on, or other plans. Interesting.
So we are proposing to add additional modules to the Gateway in the future, and through doing that, we would try to reconfigure it to eventually become like a interplanetary transportation system. So the spacecraft that could get basically equipment and the astronauts from Earth orbit to the potential destinations in deep space. So we are proposing to do that through series of 5 phases. We will be adding first of all some additional habitat modules, so we can increase the habitat volume inside the space station. Yeah, we can go back.
That's your multi-purpose.
Yeah, we'll get to there.
Okay, all right.
Don't let get. we should not rush it. So first of all, we want to increase the habitational volume inside the gateway, so we can house the crew for longer duration missions, and we can have more astronauts living on the gateway at the same time. And we would like to also add this multi-purpose free flyer. That will be a special type of vehicle that will be serve like as a tag vehicle. So it has two main elements. We are having a service module and we are having a pressurized section. And this service module will be able to not only boost to change the orbit of the space station, but it will also be able to pick up the elements for the gateway in the lunar orbit. So after the launch, when the elements are separated from the rocket inside low Earth orbit, the gateway would rendezvous with those, dock with them, and basically then transfer into the cislunar space where they would be incorporated into gateway. We can also use it for short crew missions, maybe fly crew to a nearby asteroid or something like that. So we can house crew for up to a month inside the vehicle itself.
In this multi-purpose flyer, they can live for up to a month, and you're talking about possibly going to asteroids and things like this. And they would depart from the gateway and come back. And we're going to hear more about this going to find an asteroid.
So the NASA was looking at the idea back in the 2010s to bring to launch a special spacecraft from Earth, and that would fly to a nearby asteroid, grab a boulder, and then bring it into a lunar orbit. And we can actually do that with this vehicle. Not only the vehicle itself can be used for such tasks, we would just add a robotic manipulator on the front, but we can also...
We got a slide of that towards the end showing that on there,
But we can also use basically the vehicle to get the crew from the gateway to that asteroid and then bring them back to the gateway.
Wow. So the best thing that could happen for Europe and this multi-purpose flyer is for them to discover an asteroid that's made of gold or silver, because then you'll have people falling over themselves to finance that to bring it back to Earth.
But we are not done yet. We could actually use this spacecraft to remotely or to service the other spacecraft, or we can just use it as an experimental platform. Put the experiments on it directly, fly to some exotic environments like Van Allen's belt, and testing the equipment there. So it's really multi-purpose.
What's the propulsion system proposed?
So we are proposing a combination between the ion and the chemical engines.
Mm-hmm.
So we will use the chemical engines for short duration maneuvers. So when you're having to do like orbit insertion burn or something like that.
Rendezvous.
Rendezvous, we would use the chemical engines. But for the long transfer stages of the mission profiles, we would use the ion engines.
Ion engine are most people are familiar with. Briefly tell how an ion engine works.
Basically, you're having a tank of gas, usually xenon or argon, and that one gets basically pushed. There is like a coil. We use basically electricity to propel the molecules into a certain direction, basically to create exhaust.
And there's a constant exhaust. It's not a 30-second or anything. It goes for days where the push keeps getting bigger and bigger and bigger. But it's a very efficient method. You just need a lot of electricity, correct?
Yeah, we don't
How
get
many
much
kilowatts you talking about?
So for the multi-purpose free flyer, we are talking about 100 kilowatts. 100 kilowatts.
100 kilowatts?
Yeah.
Okay. Well, let's get...
So that's it. This would be free flyer that would be
Boy,
added.
that is a multi-purpose for sure.
Yeah, and we can usually, one of the ideas, or basically the original idea was to create a vehicle that would be able to basically transfer supplies and experiments from the ISS in low Earth orbit and gateway and bring them back. So in this way, we can basically send the supplies on a single resupply mission directly to the ISS, and then astronauts can transfer it between the spacecraft.
Interesting. All right.
And then in phase 2, we are adding the first utility modules that will give us the guidance, navigation, and control of the space station, and also provide us the thermal control, and another habitation module to furthermore increase the pressurized volume of the space.
That's a big solar panel.
Yeah, that's a big. We are gonna use them. We will need them later. You will see why. So on the third phase, we are finally adding the most important module. We are proposing to add the most important module. That would be the cupola module, at least for the astronauts.
Oh, cupola.
That's the most important one.
Yeah, right. Absolutely. Well, for your own well-being, really, to look out. I noticed that the multi-purpose hab. I didn't see any windows in it.
Yeah. We have 4 windows, but they are quite small.
Okay.
But cupola really gives you an impression you are floating there in space, even though you are inside a pressurized vessel. And it also allows astronauts to take some nice pictures and do reconnaissance missions directly from orbit. So it's definitely a module that should be there for any mission, in my opinion.
Absolutely, you need to
because the pictures taken from the cupola module are usually the ones that inspire people to then furthermore dream to work maybe in the aerospace field.
Absolutely, seeing the astronauts in the cupola and the Earth behind. Sometimes there's a Soyuz spacecraft, in the background, or the Dragon, But wow, look at those solar panels. That is like that's like 4 or 5 soccer fields there.
And then in phase 4, we finally start basically the conversion from being a space station to being a transportation spacecraft. The spacecraft that is capable of transporting payloads between orbits. So we add basically, we call them propellant modules. Those include the fuel tanks and the engines, and some avionics for the engines themselves. We are proposing to use a combination between between the chemical and the ion propulsion. For the chemical, we are looking at probably at metalox, so methane and liquid oxygen as a propellant combination. This would also allow us that those tanks on basically on the gateway could be used to refuel the Starship directly there on.
Refueling the Starship that would be attached to this at some point. Where would the docking of the Starship occur on this model?
Oh, where the Starship would dock with either the Nadir or Zenith docking port.
The Nadir at the top, or the Zenith at the top, or Nadir will be the docking.
On the bottom. So it will have to dock in such orientation that it avoids the collision with the solar panels.
Right. Yeah. It looks like there ain't much room though.
Yeah,
much room there.
We are working on tight tolerance.
Who's building the docking system?
So we would be using the International Docking Adapter. This one was specifically designed for the future space missions to basically standardize the docking ports between the spacecraft.
Okay.
So we are having a single docking system. So a spacecraft basically any spacecraft can then dock with another one. And then in phase 5, we actually complete our transition from the space station to the transport spacecraft by installing
transport spacecraft that you could take this whole thing to orbit Mars?
Probably,
or go to an asteroid?
So yeah, we cannot. So we are at this point we are having this spacecraft that can be used as a space station, as a transport spacecraft. So we can basically collect the astronauts here in the lower orbit and then fly them into deep space. As you can see, we are having the propulsion systems are all doubled. So in case there is a failure, we don't really need to change any modules. We just flip the spacecraft around and we can trust the engines on the other side. And also our other systems are basically duplicated. The same goes for the solar panels, avionics, telecommunication, GNC, and so on.
My question is the solar panels again. Obviously, I'm fixed with them. Europe's kind of a nuclear-powered nuclear-powered part of our country. Why weren't we using nuclear energy on this?
Because first of all, it's much safer for the astronauts to use if they are not close to the RTG, so nuclear reactors.
RTG, radio, radiothermal generators. Yes, there you go.
That's the one point. The second one, this solar panels can be upgraded later in the mission. So this spacecraft, our idea is the spacecraft is fully modular. So if you want to replace some modules or upgrade them, you just switch them. So you don't have to design the spacecraft completely from scratch and incorporate those new improvements into design. You just do it one module by one.
Okay. And also, you need the energy from these big panels
Panels.
if you're going to go interplanetary to
Yeah.
Mars, where the sun is a lot dimmer than around the Earth and so forth. So.
Yeah, and each ion engine we are using, we are proposing to use the Vasimir from the Ad Astra, and each of those engines consumes about 200 kilowatts of
200
power.
kilowatts of power. Wow. But
But
here's
our work is not only focused on we are not only designing the gateway, we have to also design the architecture around it. And one of the important aspects, if we are trying to be really reusable, having a reusable spacecraft, is we also reuse the components that were initially meant for the gateway but are not incorporated in our concept. So in this case here we're having an example of the power and propulsion element. So this is one of the initial modules that will fly to the as part of the gateway in 2025. And we are proposing to use it for three main purposes. We would basically convert it into, we would add like a adapter in front of it in the forward section on the forward docking port.
which is the sketch on the white here, right above there, the white
yeah.
areas which you're
And this
adding.
adapter then could be docked with other. So the PPE could be used for as an experimental platform. You could attach like a platform with experiments, similar to the one that's already at the Kibo module on the ISS,
Right.
and run the experiment somewhere, maybe in deep space.
Yeah.
Maybe you can put a space telescope or something like that. So
We're all for
it's
that.
all
a
open
space
field.
telescope.
Yeah, it's all open field. We can add a grapple unit to get and collect the asteroid.
So
and
the
bring it
middle
to
one is the dotted area you see there is adding to the whole gateway concept.
Yeah.
Giant arms to capture a
asteroid and bring it to the lunar orbit, where we can then use the MFF, so the multi-purpose free flyer, to fly the crew from the gateway and dock with the PPE that has already captured an asteroid, and then astronauts can analyze it and bring samples back without flying actually into deep space to meet the asteroid.
Okay.
So basically, we are bringing asteroids to them.
Right.
That's the
These could be
idea.
autonomous also.
Yeah.
Unmanned.
Unmanned, yeah.
It could be.
So the PPE element is actually unmanned. So it's like basically very similar to ordinary satellite. It's just a bit more improved version, and then we can. It could also be used as a service vehicle. So it could be used as either as a life extension vehicle or the maintenance. So in case of the life extension vehicle, the PPE would actually dock with the satellite and then provide the attitude control to it and change maybe its orbit. While in case of the maintenance, there would be like a small robotic arm that would be able to maybe replace some of the components on the outside of the satellite.
Well, that could be applied to the Hubble telescope. Of course, this is like a decade or more plan down the road. This is like a 20-year plan, isn't it?
Yeah.
Something like that. But this could come into play to salvage or the Webb telescope, or refuel the Webb telescope, perhaps, right?
Yeah.
Okay.
And we had to do that because we were told that we cannot just throw a multi-billion-dollar element and smash it into a lunar surface and create some seismic data.
Yeah, that's the European philosophy. We're not going to just have disposable things we're going to put in space. We're going to have if it can't be used for once it outlives its purpose for this, we're going to make sure we can adapt it to a new thing. So here's the whole layout there of the European Space Agency plan.
So we did pretty much similar. We are working with Airbus to basically make sure their vehicle is can be used for multiple purposes. So the moon cruiser they are proposing could not be. We are looking into some concepts to not only use it as a resupply vehicle or a tug element, but to also use the pressurized section of the vehicle as a temporary module on the gateway to increase the habitational space for the astronauts. And those are just some of the, those are just some of the things we are working on. Hopefully, we gave you a bit of a glimpse, a sneak peek into the work we are doing.
Well, we do thank
great-
you for giving us a sneak peek into the work that the European Space Agency is doing with the EuroMoonMars project. And Bernard Foyne is the team leader of this, and he's been involved in a lot of European. The Mars Express is one of my favorite ones, Bernard, and we're going to have him on Stay Curious as well as some of your other friends. We've got Denny Noah watching and Marique Fenstra. Those names mean anything to you?
Not really.
Okay,
Don't
well, I thought you
ring
might
any
have-
bell.
But we thank you all for watching us, and what a fascinating Stay Curious we've had today with you, Rok Kete. Really appreciate this little overview that I don't think any of you have seen before about the intentions. Particularly intriguing that these are all going to be reusable type of vehicles once they get them in orbit. Why not? Like you said, Rok, we're not going to send them smashing into the moon to get them out of the way or into the Earth's oceans. We're going to get them to different locations in our interplanetary
Space.
this exploration there.
Yeah, we should.
So fascinating, and it certainly makes an old man like me wish I was young to watch all these things that you're going to do, because
Hopefully.
as we know, you can make plans, but you can't plan the outcome.
Yeah, that's true.
Correct?
That's correct.
We've got another question there, Marty.
My question,
Uh-huh.
everything you said was automated,
Yeah,
including the command service module going to the gateway,
yeah,
including the landing.
yeah.
What if we had a problem like we had in Apollo 13 or a problem like we had in Apollo 11
So,
where Armstrong took manual control?
so we are.
Can the astronauts take manual control and override automation?
Yeah, that would be possible, but we also designed the spacecraft itself to be that way that even if one module fail, we can still operate without it. We are having all the systems are at least duplicated, and even if it's one of the core modules, we are still having like proposing inflatable tunnels that could still be used to connect the other modules, and so the spacecraft could operate, without any. There would be a bit of disruption to the mission, but a minimal one.
Good question, Marty.
Because we have to already plan that, especially if we are going to be flying close to the asteroids. There are a lot of small micrometeorites around the asteroids, or especially in the asteroid belts. So we already had to plan for that one, and that's where our redundancy comes from. Yeah.
Well, we hope that you've enjoyed this hour with us on Stay Curious and our new European friend here, Rok Kete, and his whole team. It was great to sit on your meeting today at 11 o'clock, 5 o'clock
Yeah.
their time. There's a 6-hour difference there. So one of these days we'll be talking to you over there in Europe at 10 o'clock at night, I hope. But we might get you back after the launch here.
Yeah.
How soon you got to scoot back after that April 20th launch?
I don't know on top of my head. It depends when the mission
That's
will
right.
actually be launched.
Well, tell everybody what you're going to be doing this weekend.
So after that, I'm departing for the Space Symposium in Colorado Springs. Hopefully, we get to meet with some guys from NASA and other your American commercial companies,
Mm-hmm.
and planting things that are for ahead.
Good.
So
Good.
hopefully-
Well, best of luck to you. Okay.
Thank you very much for
And
having me on the
thank you
show.
for being our friend museum, and this is really the future here, right here on Stay Curious with Rok Kete. So, Marty, thank you for a smooth show again, and all you do. And we've had a lot of visitors here at the American Space Museum. Triple T was here giving them a tour, but we bumped his appearance today to have Rok here. He has to go to Colorado Springs for the space symposium there, and that a lot of other people I know are going to that. So, thank you so much. We can't wait to have you back. And everybody, we've concluded another week of Stay Curious, and glad that you were with us today. Please tell your friends to subscribe to us, follow us, and share us with all your friends out there to get great content like this. So we'll kick it off again next week. And on behalf of our museum here at the American Space Museum, I'm Mark Marquette, and we'll see you again to bridge the space between us.
Have a good day, everybody.